Assalamualaikum and good morning to everyone here, my friends, Dr. Najib. Thank you for letting me be present again for this week. So last week my friends, my friends have already presented about the feedback loop in thermal power plant, and the thermal power plant that we're designing today is for the 500 megawatts coal-fired power plant. So, oh my God. Okay, so I will just skip to the sensor that I will use for my part only. So the sensor that I use is the RTD thermometer to measure the temperature. The detail about the sensor is it use the plutonium 100 PT100 type of RTD sensors, and it measures from 0 to 600 degrees Celsius, and the output signal, the output protocol is 4 to 20 milliamp. The 4 to 20 milliamp is a type of protocol that exerted by the transmitter part of the sensor itself, and then then we will convert it into the readable signal that we know about the temperature at the sensors. Alright, so I skip the rest and I'll go straight to the lab view system of the lab view system. So when we were designing the lab view, we are taking only parts of the power plant itself, which is straight coming from the coal. Coal is the firing, the like the fuel. Coal, yeah, you guys know coal, right? Okay, so the coal will be injected into, actually there's one more step here, but we just keep that. We just want to keep for simplicity for everyone to understand. There is a pulverizer in between here, but we skip that. We are just assuming that this coal is already pulverized and is pushed into the furnace for the combustion. And then inside the furnace, when there's much coal, when there's a lot of coal, the furnace will fire extremely. So the heat will increase and it will heat up the water inside the boiler, and hence the water inside the boiler will change into steam, and the steam get transported into the generator itself. So here is the water that feed into the boiler. So the four sensors that we are using, which is the temperature sensors, the load cell, and also the motor encoder, just to calculate the mass flow of the coal itself, and also the differential pressure sensor with an orifice plate inside the water here to measure the differences between the pressure caused by the orifice plate to know the flow of the water, and also lastly is the pressure sensor at the main steam line, so that we know how much pressure of the steam we achieve through all this system. So because we are doing feedback loop, there are two loops that we are doing today. First is
The big is like presentation.
Oh yeah.
Then it's small.
Okay. So there's two loops that we're doing today. One is the relation between the coal mass and also the temperature inside the boiler itself. And also the other one is the feed water and also the pressure. So the relation is actually when the belt speed increase, meaning that more coal is fed into the furnace, the temperature will rise. And here, when the feed water is low, then the pressure increase. So actually I tried to close the whole loop, but it always not balanced. I tried to close the whole loop. I mean, these two loops actually, you can close into one loop, but I just haven't achieved that yet. So here, as we can see, here is the coal, the mass flow of the coal is measured in ton per hour. and also there's a temperature reading of the sensor inside the boiler itself, and also the pressure of the steam that coming out from the boiler. So I think it's better for me to just show this simulation straight away. But for that, okay. So okay, I'll start it. As you can see, the temperature did not even increase because of there's no coal. There's no coal is flowing inside the furnace. But if I push out the coal, then only the temperature will increase as well. So now some of you might wonder why, how can if the furnace is not blast up, if the coal didn't enter the furnace and it's not blast up, how can there be pressure? That is what I mean by these are two separated loops. They are not integrated. Supposedly they should be integrated. So then only the pressure also can react to the mass flow of the coal itself. Okay. So as you can see here, when we set to 500, the feedback loop will always give feedback for the temperature to maintain at 500.
Last 1 minute, and then I will stop you.
Alright. So behind here, for my sensor, I break it down into 3 parts, which is the resistive element itself, and then also the transmitter, and also the scale and offset. So the resistive element itself, it's determined how do we find the R, the resistance inside the RTD thermometer itself. So actually, when the sensor selected, because it's used PT100, then the equation is RT equal to, is given. This is a given equation. We call this as a Callender-Vanderson equation. And also the R0, because we use PT100 at for when the resistance, when the temperature is at 0, then the resistance is 100 ohm, and the PAT is the constant, and also the T is the temperature. Then actually this equation, when you want to convert back, because now you get the signal in terms of resistance, and when you want to convert back into the temperature, you need to actually find back the T itself. And when you realize about this equation, when you push and you rearrange, it's actually a quadratic equation. So you can find it using the B minus square root 4AC over 2B. So you can find the T back, which is in this process. Here, in this process. And then it changed into the electrical, to the current signal, the 4 to 20, and then it scale and offset here to match back to the original temperature. So I think, and another one to cover, just simple short, because we are using the feedback loop is giving feedback based on the time that we put into the feedback, the PID control itself. So the sample always come, let's say I set 0.1 millisecond, right? So the sample always come every 0.1 second. So that's why our model for every system need to be dynamic. It cannot be static, because if it's static, then there's no rate of change there. So
Okay,
I think that's it.
So you covered for RTD only, or you covered the whole?
I cover RTD only.
So you are explaining the whole, right?
I explain RTD mostly.
So again for the feedback, you couldn't manage to get it, correct?
Yeah, I couldn't close both loop.
So basically the idea, what is the idea?
Actually, the final objective is I want I want the pole to be the manipulated variable, the mass flow of the vehicle to be the manipulated variable. That and
So
the
what? Answer me in the simplest way.
okay.
What is the purpose of the feedback in your temperature sensor? Temperature sensor.
Purpose of temperature is to ensure that the temperature is reached and managed to stay at the set point.
Maintain. Yeah?
Maintain at the set point.
Okay, thank you very much.
Okay, that's it.
Okay, our final group.